Hello, welcome back. And for today's lesson, we will be covering section 1.3, solving equations. So our first objective is we're going to define what equivalent equations are and see if we can identify equations that are equivalent. Okay, so equivalent equations are just two equations are equivalent if they have the same solutions. Solution or solutions. I like to say the same solution set. Okay, so two equations are equivalent if they have the same solution set, more specifically. So here's an example. Determine whether 5x equals 30 and 3x equals 18 are equivalent equations. Okay, now if you recall, to be a solution to equation means that you can substitute it in for the variable, substitute that value in for the variable, and it makes it a true statement. Okay, so the only solution for this equation is x equals 6, because when you substitute 6 in, 5 times 6 is 30, that's a true statement. And there's nothing else that works. So x equals 6 is the only solution, and if we're talking about sets, I would say the solution set is 6. Now for 3x equals 18, again here the only thing that's going to work for this equation is 6, because 3 times 6 is 18 and nothing else would work. So that solution set is also 6. And since both of these solution sets are the same, okay, they have to be identical. There's only 6 and nothing else for both of them. So these equations are equivalent. Let's try another one. So how about, this is exercise 14 from the book. Three x minus 4 equals 8, and 3x equals 12. And here again, let's see, add 4, divide by 3, and we'll review this in a little bit. So the solution set for this one is 4, and the solution set for this one is also 4. So here again, these two equations are equivalent. Okay, let's review solving equations. So let's go on to the next objective, solving equations using the addition and multiplication principle. So, which commonly we refer to these as the golden rule of algebra. Let's just review it real quick. So the addition. Okay, the addition and multiplication principles for equations. For any real numbers, A, B, and C, so we don't have any restrictions on A, B, and C, A equals B is equivalent to A plus C equals B plus C. And A equals B is equivalent to A times C equals B times C, provided C is not equal to 0. Okay, so again, what I like to remind people is to understand, okay, so the addition principle for equations, if you just say A equals B is equivalent to A plus C equals B plus C, it's not very meaningful. So you need to translate this to something that's a little more meaningful. So basically what we're saying is if you have an equation that's true, right? So remember, we just defined what it means for two equations to be equivalent. So if you have these two equations, for this to be true, for them to be equivalent, that says that the solution set for this equation has to match the solution set for this equation. So what this principle is saying is if you have an equation, you can add any number you want as long as you add it to both sides, and you get an equivalent equation, meaning that the solution set for this equation is the same as the solution set to that equation. And it works the same for multiplying. So for addition or multiplication, if you have an equation, you can add any number you want as long as you do it to both sides, or you can multiply any number you want as long as you do it to both sides, and C can't be 0 though, right? The reason you don't want to do this is basically what will happen is you'll wipe out all the information, because any number times 0 is still 0, is 0. So you'll get 0 equals 0, and that won't be very helpful. So you'll lose all your information. So again, we commonly refer to these as the golden rule of algebra. Basically, what you do to one side So what you do to one side of an equation, you must do to the other. So if we had an equation, x plus 5 equals 12, I can add any number I want to that equation as long as I add it to both sides. So these would be equivalent equations. Again, you could see that 7 plus 5 is 12, and 7 plus 5 plus 8, that would be 7 plus 5 is 12 plus 8 is 20. And this side's 20. So 7 is a solution to both of these. And the idea is you're going to use this principle because not to make equations more complicated, we want to get, our goal is to get this x all by itself. So what I would do in this case is, so if I had x plus 5 equals 12, and I were to add a negative 5 to both sides, this equation is equivalent to this equation by that principle, the addition principle for equations. And then we can simplify this expression. We know any number plus its opposite is 0. And then any number plus 0 is itself, so that just gets me 12. And then 12 plus negative 5 is 7. And so since I just simplified both sides, I didn't change the equation, so I know that the solution set, that these are equivalent expressions or equations. Now, if I follow the logic here, if this equation is equivalent to this equation, and this equation is equivalent to this equation, that means the solution set for all these are the same. And then this bottom one, you could just read it off. What's the solution to this? Well, for this to be true, x would have to be equal to 7. So the solution set's 7. And we can follow the logic all the way back up. So if these are all equivalent equations, then the solution set for the original problem, original equation, has to also be 7. So that's the idea when you're solving equations. All right, and now on to combining like terms. So let's review what like terms are. So if a term is a number a variable, a product of numbers and variables and or variables, or a quotient of numbers and or variables. So terms are things like this: ax to the third, or just a number by itself, or set a quotient 4 divided by y. That would be a term. And I can have even more than one variable. I can have like negative 4 a b cubed c. Okay, so those are all terms. Now in algebraic expressions, we can see, so terms, the way you kind of identify it, terms in an algebraic expression are separated by addition signs. So here's an algebraic expression. Have 1, 2, 3, 4 terms. So the terms are 4x, 3y, 7x, y squared, plus 8. Now notice I didn't say plus or minus signs, I just said plus signs. But technically, this is the way you think of it, but we always redefine subtraction is adding the opposite. So if I had 3x minus 7y plus 8, how many terms are here? And the answer is, well, you got to think of this as 3x plus a negative 7y plus 8. And you see there's 1, 2, 3 terms. So this, okay, so let's state the number of terms. So this has 1, 2, 3, 4 terms. And this has 1, 2, 3 terms. Okay. Now combining like terms, so well, those are terms. What are like terms? Like terms are terms that have exactly the same variable part. That's kind of the way I think of it. What do I mean by that? It has to be the same variables with the same exponents. So for instance, if you had 5x squared and 7x squared, they both have x squared. See, that's the variable part. Those match exactly, so those are like terms. Three ab squared and negative 8a squared b are not like terms. They both have a, b as variables, but a is to the first power in this one, and a is to the second power in this one. So those don't match. So right there, they're not like terms, and the b's don't match either. So we got b the second, b the first. Okay, so everything is, you ignore the coefficient, the number in front, and you just look at the variable part. They have to match exactly to be like terms. Now to combine like terms, hopefully this is all review, but anyway, we'll just talk about it quickly. To combine like terms, we're just going to, you leave the variable part alone. And add the coefficients, the numbers in front. So if I had like 5x squared plus 7x squared, to combine like terms, you're going to leave the x squares alone, and you're just going to add the numbers in front, the 5 plus 7. And a lot of people don't realize what we're really doing when you're combining like terms is you're using the distributive property in reverse. See, so we know multiplication is commutative, so actually I can put that x squared in the front, and when you distribute it, you got 5x squared plus 7x squared. So we're actually doing the distributive property backwards from the way that we normally think about it. Okay, so 5x squared plus 7x squared, and you don't have to show the step, obviously, right? You're just going to add 5 plus 7 and get 12, and just write 12 down. So I can say combine like terms. I could say simplify. So here I'm going to say combine like terms, 3x plus 4y plus 2 plus 5x. So the only like terms are the x terms. Those are like terms, so I combine them. I add the numbers in front. 3 plus 5 is 8. Leave the x alone, and then write everything else down that doesn't have like terms. Okay, so if I had 8a minus 3b plus 7b minus 12a plus 4. So our like terms, we've got the a's. So I got positive 8. And remember, you got to think of this as plus and negative 12. So positive 8, negative 12 is negative 4. They're a's. Negative 3b plus 7b, that'll be a positive 4b. And then I got the last term plus 4. So there you go. Okay, let's try a couple exercises from the book. And the directions here are simplify to form an equivalent expression by combining like terms. Use the distributive law as needed. So let's try a little more difficult ones here. How about, let's start with 40. So we got 14y plus 6 minus 9y plus 7. And again, we're going to look for like terms. So 14y minus 9y is 5y. And then the numbers just by themselves, since they have no variable part, they're like terms. Positive 6 plus 7 is positive 13, so we're at plus 13. And let's try number 44. 5x plus 4x plus 11. So my first thing is using order operations, I want to get rid of these parentheses. Now since I can't work inside, I don't know what x plus 11 is since I don't know x. They're not like terms, can't combine them. So my way around it is I do the distributive property to get rid of these parentheses. So I'm going to take 4 times x, which is 4x, 4 times 11, which is 44. Okay, now back to combining like terms. These are both x terms. So 5 plus 4 is 9. And the 44 is not like, so I just leave it. Can't do anything else with this. You're done. Simplified. Okay, how about number 50? 8x minus 9 minus parenthesis 7 minus 5x. Now there's two ways to consider this minus sign. You can think of it as negative 1 times the parentheses, and then you're going to distribute the negative 1. Or you can think of it as opposite, and you just change both these signs. Either way, I say just distribute the minus sign, meaning I'm going to take this positive 7 and it's going to become negative 7. And whether I write the plus here or not, it's there. Then minus, so if I think of it as negative 1 times negative 5 is positive 5x. If I think of it as just change the sign, this is negative 5x, it becomes positive 5x. So either way, you should end up with this result. Okay, now we're going to go combine like terms. So x, I got positive 8 plus positive 5. That gives me 13 x's. And then combine the numbers, negative 9 plus negative 7. See how I'm thinking of that? Negative 7. So negative 9 plus negative 7 is negative 16. And then I write minus 16. Okay. Now let's try a very difficult one here. It's number 60. So we got 2y plus 7, 3, 2y minus 5 minus 8y plus 7 plus 9. All right, so first off, whether you use parentheses, brackets, or braces, it doesn't matter. Typically, this is the order of precedence, right? So parentheses are like first level, brackets second level, braces third level. But what we find now, especially with computer science, is we just use parentheses for all these. Okay, so, and they always come in sets. You got an open one, see this is an open one, open, closed, open, close, here's my close, close. So they go like that. And with parentheses, you always work inside out. So we're going to do the innermost ones first. So we're going to do this one first, and this one. You're going to do these separately. Now notice, again, by order operations, you do inside the parentheses. Well, you can't do anything with this because they're not like terms. So what we're going to do is, the way around it is you distribute to get rid of those parentheses. So I'm going to get 3 times 2y is 6y. 3 times 5 is 15. Again, here, there's nothing I can do, but I'm going to distribute that minus sign, or distribute the negative 1, whichever way you want to think of it. So that's going to be, this is a positive 8y. I'm going to change that sign, and it's going to become a negative 8y. It's a positive 7. I'm going to change that sign, it's going to become negative 7. Now in here, what I'm going to do first is combine like terms. So I got 6y minus 8y. So you distribute as a last resort. So 6y minus 8y is minus 2y. Negative 15 minus 7 is negative 22. Now that is inside these brackets. There's nothing else I can do. So let me write where we are right now. We got plus the 7. Inside these brackets, we have the minus 2y minus 22. Okay, that was in there. Plus the 9. Okay, so now there's nothing else I can do here. So at this point, I'm going to distribute the 7. So I got negative 14y minus 154 plus 9. I'm going to combine like terms. Minus 14y minus, see, 154 minus 9. I should be able to do that. 145. Okay, now there's nothing else I can do inside, so then that's when I do the distributive. Well, there's nothing out here, it's a positive 1, so essentially I can just drop these braces and combine like terms. Negative 2y minus 14y, and then just write down the number, and there you go. Alright, so let's solve a couple of equations. Let's try This is number 74 in the book. 8x minus 3x minus 5 equals 40. So, and the direction is just solve. Alright, so basically when I'm solving linear equations in one variable, I kind of think of it as 4 distinct steps, or 4 major goals that I'm thinking. So my first step is just simplify both sides, if necessary. Okay, so in this case, you simplify. So we're just looking at the sides individually. So on this side, you can you simplify anything? And the answer is yes. Okay, I don't know, is that a stray mark? It was. Okay, that's not there. So let me rewrite it. So basically you look at this expression and it's just like the problems we just did. I want to get rid of these parentheses, distribute the negative sign, so it'll be negative 3x minus 5. Combine like terms, it's 5x. Then on this side it's already simplified. There's nothing else you could do. So that's your first step, simplify both sides. That can be a lot of work for some problems or no work at all. I could have this original problem on one side of the equation and another thing similar to this on the other side. So for this problem like that would take a lot of work for this one major step here, or goal, I would say. My next thing is I want to use the addition property. Now when we say addition property, we mean addition or subtraction. Subtraction is adding the opposite. To get all the variable terms on one side. So here, if I had a 3x on this side and a 5x on this side, I'm going to subtract 3x from both sides, so that way I would only have the variable on one side of the equation. Now from there, for step 3 and 4, so we're down to, so step 2 we didn't have to do anything, so that wasn't necessary. Step 3 here, or my goal 3, is I want to get my ultimate goal is to get x by itself. So what I need to do is get rid of this minus 5 and this times 5. So you always do order operations actually in reverse when we're solving equations. So I want to get rid of this minus 5 first. So on the side of the variable, you want to get rid of I always say stuff, right? But what I mean is get rid of the constant. Constant term is the term with no variable. So, and you do it by doing the opposite operation. If this is minus 5, we're going to add 5 to both sides. So we get 5x equals 45. And then your last step is you're on the side of the variable. So we don't care about that number right yet. On this side, we got 5 times x. So we want to get rid of the 5 So I always say in class, multiply, divide stuff for my very loose language here. So get rid of the multiply, divide stuff. So what do I mean? The coefficient. And again, you're going to do the opposite operation. So if this is, you got x times 5, you're going to do the reverse of that. You're going to take x, 5x divided by 5. And the golden rule, what you do to one side, you do the other. And then here, 5x divided by 5 is just x. 45 divided by 5 is 9. And we attain our ultimate goal, again, x by itself. And since we just did simplifying sides, that creates an equivalent equation. And using the addition and multiplication properties creates equivalent equations. So all these equations are equivalent to each other, meaning the solution set to this equation is the same as the solution set to the original question. So we know our solution set is 9 if I write it using set notation. So you can write it either way, this way or this way. Okay, so for our last topic is types of equations. So basically there's 3 types of equations that we deal with in algebra. We have what's called an identity. So here we go, types of equations. So an identity is an equation that is true for all replacements of the variable. So an identity is an equation that's true for all replacements of the variable. The way I usually say it, an identity is an equation that's always true. Okay, always true. So if it's always true, what's the solution set? Now remember, the solution set is any value that when you plug it in an equation, it makes it true. So if all the values that you put in for x, all the replacement values, make it a true statement because it's always true, what would the solution set be? So the solution set would be, or we'll just say is, the set of real numbers. Because everything works. If it's always true, everything works. And again, the symbol for that would be there. Okay, so the set of all real numbers. A contradiction is an equation that is false for all replacements. Again, I usually say always false, which means never true. So this always gets people when I ask in class, okay, so what's solution set? And again, the solution set is all the things that make the statement true. Well, if the statement's never true, if it's a contradiction, it's always false. It's always false, so it's never true. So what makes it a true statement? Well, if it's never true, then nothing makes it true. So the solution set is empty. So we call it the empty set. So that's this symbol. This is not a number. It's a set that contains nothing. It's the empty set, or you can call it the null set. That's the other term. Null set. So you'd say that you would write out in words no solution, or you can write the symbol for the empty set, meaning there's no solution. And then the third equation would be a conditional. Now these are the ones that we deal with mostly in algebra. So a conditional equation is sometimes true and sometimes false. Depending on the variable. On the value of the variable. Okay. So its solution set is the things that make it true. Okay, that's what its solution set is, the set of values that makes it a true statement. So identify the type, solve each of the following equations, and classify the equation as an identity, contradiction, or a conditional statement. So let's look at exercise 86. We're going to solve and identify, or I should say classify, as conditional, identity, or a contradiction. All right, so the way you do this is just solve it just like it was any old problem. Don't worry about this yet, and see what happens. So we're going to combine like terms, simplify both sides. Okay. Then, or next up, get all the t's on one side. So I'm going to subtract 14. Okay, now at this point, once you see that the variables fall out of the equation and there's no variables left, what you're left with is this number sentence. Whenever you get a number sentence, then you ask yourself, is this a true statement or a false statement? And you can see that it's true, 5 equals 5. And since there's no variable in this sentence anymore, it doesn't matter what you choose, the value of the variable will be, it's going to be a true statement. And then these are all equivalent equations. So if this is always true, that means that's always going to be true. So this is an identity. And the solution set is set of all real numbers. Okay, so we solve it by identifying the solution set. It's a set of all real numbers. And then it's a classify. Oops, I spelled that wrong. This is an identity. Okay, so that's the two parts. Now, if you had an equation where you got like, so you start out with something and you end up, the variables fall out and you ended up with like 8 equals 12, you say, hey, okay, there's no variables in this equation anymore. So this is always false. Now remember, solutions are what makes it true. Well, if it's always false, it's never true. So you can write out no solution. And then you would say that's a contradiction. Okay. If you work out an equation and the variables don't all go away and you end up with x equals 7, then obviously the solution set is 7. And then that's a conditional statement, a conditional equation. So those are the three types of equations. So you got an identity that's always true. So the solution set's all real numbers. A contradiction that's always false. So that has no solution. Again, you can write, instead of writing no solution, that's the solution set. It's the empty set. And then a conditional statement where it's true if x is 7, and then false anytime else. So it's sometimes true, sometimes false. So that's a conditional statement. All right, so that concludes today's lesson. Go to MyMathLab and complete the exercise.